In the previous video, we generated some PID coefficients using a manual tuning method. Let's run some tests to see how well it works. I'll go to the ISA PID algorithm in the spreadsheet. We want the parameters optimized for set point changes, and let's start with the PI numbers. I'll put those in here. And let's use 1 second for the sample time because we know from the previous video that it's close to what the PI autotune will give us. That'll give us more of an apples-to-apples comparison. You want the sample time to be faster than your process responds. We're doing temperature, which takes several seconds to respond, so 1 second should be fine. Write them out and make sure we're in auto mode. I'll bump the set point up 5 degrees like we did before, fast forward, and the Click PLC automatically adjusted the PID output to get us to the new set point quickly and efficiently. Exactly what we expect. I'll go to the 100 degrees like we did before, and then back to the 110 degrees. Looks pretty good. The cool thing about this manual method is it's an open loop tuning. That is, we put the PID function in manual mode, did a 5% bump, and took some measurements. It doesn't rely on the Click PLC's PID algorithm at all, which makes it a good independent way to verify your auto-tune results because all of the tunings we did in the previous videos were closed loop. They actually use the PID function in auto mode to monitor the process variable, do the 3 cycles, and make a decision. Which begs the question, how does this manual tuning compare to the auto tuning we've been doing? Let's make sure we're in PI mode, do an auto tune, and let her rip. I'll fast forward through that, and we see the 3 cycles of the auto tuning. Yep, looks good. Fast forward through our usual set point steps, and look at that. This is the manual tuning, and this is the auto tuning. Our manual tuning is looking pretty good. Okay, let's try the PI and D version of our manual tuning. I'll just take the results from our spreadsheet and put them in here. And I'll use one of the sample times we got from an auto tune in the previous video so we have an apples-to-apples comparison. Fast forward through our usual set points, and look at that. It's even better than the PI version. And in general, you'll find that temperature PID applications will almost always work better with the full PI and D coefficient set, while just P and I will usually be fine for most other industrial applications. Okay, let's compare that with the auto-tune version. I'll select the PI and D version and let her rip. Fast forward, and we see the closed loop 3-cycle auto-tune and the new parameters in the PLC. Looks good. And fast forward through our usual 3 set points. Well, how about that? This is the manual tuning, this is the 3-cycle auto-tune, and this is the auto-tune result. The manual tune nails it. Very cool. Here's a look at all 4 side by side. PI manual tune, PI auto tune, PID manual tune, PID auto tune. Looks like our manual PID tuning is going to give us the cleanest response for this system. Let's put our manual PID coefficients back in and do one more experiment. We've been changing the set point. Let's change the load. I'll close most of the vent holes on the enclosure, which will reduce airflow, so we should need less heat or power. Will PID adjust accordingly? I'll fast forward, and yep, we see that PID automatically lowered the output to accommodate the new load. Open the holes back up and fast forward, and PID automatically adjusted the heater power again to maintain the set point. Perfect. Now we did that using coefficients optimized for set point changes. But we changed the load. So we really should be using the coefficients that are optimized for load changes, right? Yeah, well, I've never had any luck with those, and these work just fine, so I use them. When I do use the load change equations, I get results like this. Let me know if you figure out what I'm missing here. Anyway, the bottom line is, you now have several ways you can tune a PID loop. The Click PLC closed loop auto tune PI and PID, and the open loop manual tune method for P, PI, PID for both set point and load changes, and for all 3 types of PID equations. How about that? There are a couple things you need to be aware of. This manual tuning we did in this video was for this specific self-regulating type of system. Don't assume that what we did here will work for all systems, And don't assume my spreadsheet will work for your system until you've taken the time to understand how this method works. I skipped some things I knew weren't important or required for this demo, but they might be real important for your system. Check out the PID Blueprint website to see how to do other kinds of PID systems and to learn more about this method. And remember, please don't call Automation Direct support team about this method. It isn't an Automation Direct product, so they can't support it. Click here to see the other videos in this Click PID series. Click here to learn about Automation Direct's free tech support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.